All right, so this is the Section 9 Enrichment packet in which we're going to be going over. I folded up this paper and it's all raggedy in my bag, so that's that. But before we start, I'm going to start with question number 8 from the Section 9 Circles Enrichment practice that we did over 2 classes. And you should have on you, I said that question number 8 was going to be like one of the questions on the exam. So I want to make sure that everybody has that completed. And so therefore, you know how to answer it, what to do, and to go from there. So a circular swimming pool has a rope directly through the middle that is 25 feet long, and the owners want to paint the bottom of the pool a beautiful sea green. Each bucket of paint covers 100 square feet. How many buckets must be purchased to cover the bottom of the pool? The area of the garden, of course, should say area of pool. Okay, and then we're going to look for this in square feet. They ask us to round to the nearest foot. Please remember that rounding to the nearest foot means rounding to the nearest whole number. The very first thing that you should do is draw a circle to represent the pool. And of course, after drawing the circle to represent the pool, you should draw the rope. Okay, so the rope goes directly across. And we know that that rope is going to be 25 feet long. Okay, what we are looking for is the area of the bottom of the pool. So we're looking for all of the bottom of the pool, all of it. That's what we're trying to cover, the bottom of the pool. So for us to do that, we need, of course, the area formula. And so the area formula, which you will have to memorize, it will not be on the test, is going to be pi r squared. All right, you need to make sure that you know that. So now that you have the area of the circle, the only thing you need to do is fill it in. However, we weren't given the radius, we were given the diameter. And of course, to get the radius, we know that that should be exactly half of that, which would be 12.5. For us to solve for this, of course, we're going to do pi r, which was the 12.5, and then that'll be squared. This can go straight into the calculator as is. And then since it asks you to round to the nearest foot, we're going to go ahead and round this to 491, because in the calculator it would have given us 490 point something over 5. So we know that we want to round up. So when we put that, we're going to list the 491 right here. It asks us how many buckets of paint is needed. So we already know, of course, that 100 feet can cover, well, one bucket covers 100 feet. So already we see that it's more than 4 buckets because, of course, there is 491. And I should also make sure that I have feet squared. Okay, sorry. So since we know that that is the case there, what we're going to do, and it's already up here, sorry, square feet, so we're good. What we're going to do is have more than 4 buckets, which is going to be 5 buckets of paint. So we know we're going to need 5 buckets to cover. Okay, you cannot go to the store, you cannot go to Home Depot and get 4.91 buckets of paint. Okay, it will not happen. All right, so that's question number 8 on the previous worksheet that we worked on in class over the course of 2 days. Please make sure that you understand this question because it will be a question just like that on the test. From the enrichment packet, I said that we should circle question number 3 because that one is going to be on the test. 3 and 4 are very similar. We did 3 in class. Please remember that this is the equation of the circle. I always ask you to start off with the equation, which by now you should have memorized because, again, this formula will not be on the test. Remember that your center will always be your h comma k. And so you have to ask yourself, what must h be to give you a negative 1? So we know that that has to be, of course, a positive 1. And of course, what must K be? Sorry about this going back and forth. I'm going to try to get this to stop with this blurring. What must k be to give you a positive 3? And of course, we know that that's going to be a negative 3. So maybe if I do like that, and like that. Okay, so now that we have our center of the circle, the next thing that we need to have is our radius. We're not given the radius, we're given the radius squared, which equals 9. To be able to get the radius, we'd have to square root both sides, and everybody should be familiar with that. We know that the square root and the square cancels out, so we know that r is going to be 3. Now, to the best of your ability, you're going to make yourself a bootleg graph, and as discussed in class, this is going to be a multiple choice question. Is that going to go through? Okay. Because this is going to be a multiple choice question here, they're going to give you a multiple of graphs where you're going to have to be able to find the center at 1, negative 3 and the radius at 3. So here is our 0, 0 here. We're going to go over 1, that's the x value, and then down 3. 1, 2, 3, which is going to be located right here. Remember that we said that the radius was 3. So we're going to go 3 to the left, to the right, up, and down. And then that's going to give us how we draw a circle. 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. And to the best of our ability, we'll sketch our circle. Okay? And so that's it. That's our circle for that. So that's question number 3. Okay. I said that we should circle question number 6. I think we've been doing an excellent job of working with the equation of a circle. When we do this work, remember we have to do a couple of things. One, and I'm going to write over here to the side, they give us the radius. The radius is equal to 6, but we know that the radius squared, meaning 6 times 6, is going to be 36. All right, we want to make sure that we have that. Now, what we're going to do with that is continue the equation, and we'll set this up. We'll start off by, of course, always gathering our terms together. And we want to do this because I don't know if you remember what I said, but on the test, this is going to ask for the center, and it's also going to ask for the value of z, but it'll be a different variable. So now that we have our terms grouped together, we want to go ahead and move any numbers that we have, but there's no numbers on the left side that needs to be moved to the right side, so nothing we need to do. We can jump right into our b divided by 2 squared. We do that for the x value first. Remember that b value is the negative 4. This is not saying that x equals this. This is just giving us our x value. So negative 4 divided by 2 squared. Negative 2 divided by 2 is negative 2. Sorry, I did just say that. My bad. Negative 2 times 2, of course, gives us a positive 4. We'll do the same thing with y. Y was a negative 8 divided by 2, which gives us negative 4 squared, which gives us 16. Now remember, in this same step, we need to take our 4 and our 16 and add it into each family and on the other side. Z, and remember we're adding the 4, adding the 16. Okay? All right, so we're going to keep going and get this together. Remember our shortcut. Our shortcut knows that we're going to have x minus negative 2. Sorry, that's x minus 2, not x negative 2. Okay, minus negative 2. Squared plus y negative 4 squared. And remember, all of this is going to equal z plus 4 plus 16. I always ask you, always, to come back with your equation. I left off the square, which means that that would have been incorrect. And for your center, you're asking yourself, what must H be? What must H be to be a -2? So we know that that'd be positive. And then what must K be to be a -4? And we know that that one always also will be positive. So that will be our center. After coming up with our center, of course, remember this is R squared. Okay? We know that R squared is actually equal to 36 because we already know what the radius is. So 36 is going to be equal to Z plus 20. We just subtract that 20. And of course, we know that Z then will be equal to 16. Okay? And that's how we solve for that. I also asked you to circle question number 8, where you're going to convert. This is the only time in which we're going to do this. We're not converting anything else. Remember, all we have to do to convert is multiply this 180 over pi, and that's it. Okay? So, of course, 180 pi over 3 pi. We know from the beginning pi cancels out, and we're just going to divide the 3 into the 180. So you can do that longhand or you can do that mental math to see how many times it goes in there, and hopefully we're able to determine that it's 60. So the answer for that will be 60 degrees. Okay, we're doing the same exact thing. And we'll multiply straight across. And because the numbers are a little larger, let me grab my calculator. All right, so we know that that's going to be 900 pi over 4 pi. And remember, that's just going to cancel out, and we'll just divide that by 4. And we should end up with 225 degrees. Okay? So where we see convert is the only place where we are doing a conversion. If not, then we got to do some work. We got to solve for something. Number 9 and number 10 are quite similar, but of course we will run through the steps in number 9. Okay? So the very first thing that we do in number 9 is we want to work this. We want to move our terms together. So we move the x squared minus the 10x, and then the y squared minus the 12x plus 40 equals -5. And when we look at step 1, that's exactly what was done. Remember, your second step is to move your numbers, so you have to subtract the 40 from both sides. This is where a lot of you guys made a mistake. Remember, when you subtract 40, that cancels out, and this becomes a -45. Okay? So in this second step, the second step is also correct. The second step is also correct. What is not shown on the paper, and I need a separate sheet of paper. Hold on. All right, so what is not shown on the paper is, of course, when we go ahead and we do that work to get our half, right? So that b divided by 2 squared is not shown. Come on now. Okay. Now, bear with me with that. I'm sorry. Okay. That's much better. So, when we do that, then that's that negative 10 divided by 2, which of course is going to give you the negative 5 squared, which is 25. And then, of course, we do the y, which is going to be the negative 12 over 2 squared, which of course is going to give you the negative 6 squared, which gives you 36. This step is not shown, okay? What is shown in the next step is going to be the x minus 10, x squared minus 10x plus 25, and then of course the y squared minus 12y plus the 36, and of course that equaling negative 45 plus 25 plus 36. Now they went ahead and they cleaned this up in the next step already. Okay, so what we're going to see the next step look like is this. So this is the exact same as what we see right here. Okay. Now remember, this is our shortcut right here and right here. Uh-oh, sorry. Right here. So we've got x minus 5 squared plus y minus 6 squared. And all of that, of course, is going to equal 16. So we come down and see that is the next step. Check. And then, of course, for your center, we have to ask ourselves, sorry, I didn't write the equation. We have to ask ourselves, what must h be for us to get negative 5? So we know it'll be a positive 5. And what must k be to get a negative 6? We know it'll be positive 6. R squared is equal to 16. Square root both sides. We know r is equal to 4. When we check our work, we can see, uh-oh, this is where he made his mistake. Okay, so that is wrong. All right, so step 5, and that's what you would select. And then what was the mistake? He did not change his signs for the center. All right, remember number 11 and number 12. We got a little overzealous. That's not what is going to be there, so we're not going to do those. Excuse me, we're going to number 14. This one says if the radius of a circle is given, we know it's going to be 4 units. Then what is going to be the area of the shaded portion? The shaded portion is here, so you've got to do 2 steps. Step number 1 is to find the area of the sector. All right, so remember the area of the sector is going to be this measurement, the angle measurement, which is also the arc measure. And we know that that's going to be 90. How do we know? Well, the 90-degree box tells us so. So we know that'll be 90 over 360. And we know we're going to multiply that by the area of the sector. So we know that that's the area, pi r squared. And let me not write r because we actually know what r is. Yes, this eraser works. So, of course, r is going to be 4. The radius is 4. They tell us that already. 4 squared. And just like I told you in the class, you can put all of this into the calculator right away. But if you don't want to, you can reduce this. 90 into 90 goes 1. 90 into 360, of course, goes 4 times. 4 pi times 16. We know that that's going to be 1 over 4. Sorry, let me put it over 1 like that so I can just multiply straight across. So 1 times pi 16, this is going to be 16 pi. And 4 times 1 is just going to be 4. 4 divided into 16 is going to give you 4 pi. And if you put 4 pi into the calculator, it should give you 12.57. I'm rounding to the nearest hundredth because this actually is 6, and right behind it is another 6. So now that we have the arc sector, we need to have the area of a triangle. So we're going to subtract the area of a triangle. So you might be thinking, where's the triangle? If we look back at the picture, here's the triangle. And this is what we're solving for now. You might remember that the area of the triangle is going to be half the base times the height from a formula, and we should already know that. We get lucky because in the triangle, this base and height is exactly the same, 4 and 4. So 4 times 4. All right, half of 16, we know it's going to be 8. So the only math that we need to do is, of course, 1257 minus 8. And, of course, that'll give us 457 for our number. The question will tell us how to round, if we have to round at all. We have to be careful because in this next one, it asks us for the arc length, y'all, the arc length. So we know that this here is not the arc length. That's the central angle, which is also the angle measure, not the arc length. So for us to be able to utilize each of these, we need to know what each one of these angles are going to be. So starting off with the first one, we know that that's going to be here, which is 41. How do we know that it's 41? Well, this is 49, this is 90. The only remaining would be 41. Then we're going to do BOE. So we do where's my B? Sorry. BOE, which is going to be 131. How do we know? 90 plus 41. BOC will be 49. And then EOC is 180. Now in class we did the first one, so we'll do this last one. So remember, this is the arc length. The arc length is going to be 180 degrees over 360. Then we're going to multiply it by the circumference formula, which is 2 pi r, and our r in this one is also 4 units. Now again, you can put this into the calculator, and I'm so sorry I didn't say this at the top, but please make sure that this is in terms of pi. In terms of pi. So 180 can go into 181 times 180 into 360. We know can go twice. And then we're going to multiply that by 8 pi. Invisible 1 underneath that, so we know that's going to be 8 times 1, which would be 8, and then 2 times 1, which would be 2 pi, which means that 2 divided into 8 is 4 pi. So our answer for this would just be 4 pi. Okay, we should be able to answer the rest by doing the same exact thing. Question number 17, I believe that was the next one that I asked you to circle. Question number 17, you had to do a little bit of background information first before you proceeded. The very first thing you had to do was look at the whole entire circle of Q. Circle Q had 2 radiuses and, of course, our radii. I'm so sorry. The radii, of course, would be the same exact measurement. So we know that AQ would be equal to QR. Those two would be equal to each other. So that means whatever this length is, this length should be exactly the same. So in that case, if I know that this is 30, then I know the remaining of this right here needs to be 20. Okay, 20, 20, match that up. And then, of course, if this is 30, then I know that this also over here has to be 30. Therefore, making circle A and circle R congruent. The very first question they ask us in the statement is the diameter of circle R 60 centimeters. So we see that circle R has a radius of 30. And that means, of course, the diameter would be double that. So the diameter indeed would be 60 degrees. We can select A. In order to do the ratio of the circumference, we first need to know the circumference formula. The circumference formula is going to be 2 pi r okay, and the reason we're using 2 pi r instead of pi times d is because they're talking about a radius in this and not a diameter. All right, so let's go ahead and use that because that'll be quite easy to do. So what is the ratio? Ratio is usually written as a fraction. So we'll do the circumference of circle A first. So the circumference of circle A is going to be 2 pi, and then the radius of circle A was 30. And then at the bottom, we're going to put circle Q, okay? So circle Q, 2 pi, and then the radius of circle Q, you have to be careful. Circle Q is in the middle. The radius is from here to here. So that's a total of 50. The radius is 50. Then we're doing AC. So when we look at the line AC, AC is only 30. And we look at QA, QA again, we've got a total of 50. They're asking us if the ratio is the same. So right away I can see 2 over 2 cancels out. Pi over pi cancels out. So 30 over 50 and 30 over 50. Well, you know what? It is the exact same ratio. So we can select B. Now from our studies, circles get bigger, they get smaller. So they have a dilation. They do not change shape. Even if you turn them, if you flip them, it is still a circle. So we know that all circles, this symbol right here means similar. So we know that all circles are similar. Okay, so C is an answer. The next one talks about the area, so we need to know the area of a formula. Area of a circle. And remember, this is also another formula in which you're going to have to know for the test because it's not going to be given to you. So, of course, we need to find the area of both of the circles. So let's start off with circle Q. So the area for circle Q, of course, is right here in the middle, area formula. So for circle Q, we're going to do pi times radius. So the radius of circle Q is 50 squared. So when we put this into the calculator, 50 times 50 is going to give you 2,500 pi. Let's just leave it in terms of pi. We'll do the same thing for circle R. Pi 30 squared, and that'll end up as 900 squared. They want to know if the area of Q is more than twice the area of R. So, of course, twice the area of R would be 1,800. So this is definitely more than 1,800, so we can select this answer. Please, 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 please do not get lost in the sauce. This is angle AQR. Angle QAR has absolutely no markings, no markings, no markings whatsoever. Nothing tells us what it is going to be. It doesn't say it in a reading. There's no markings. And so in that case, we cannot say that this is 90 degrees. Remember, can you tell the difference between 89 degrees, 90 degrees, and 91 degrees just from looking at it? And the answer to that is absolutely no. Okay? So we cannot say that this is it. Please put no markings. Okay? So we want to know AQ plus BR, will it equal 60? So when we look at AQ, AQ is 50. BR is 30. Equals 60. So we know that 50 plus 30 is going to be 80. And 80 does not equal 60. So it doesn't work. Okay? So we cannot select that one either. That's out of the ballpark. In question number 18, Mr. Thomas is maintaining a circular pool. And this pool is going to have a radius of 50 feet. So from here to here is 50. He's constructing a fence around most of it. This fence that is going around most of it is going to start here at the opening, and it's going to work its way all the way around. Like so. We do not care about the opening because that's not where the fence is going. The fence is going where the purple is. So we need to figure out what that is going to be. And of course that's going to be 360 minus 20. And of course that simple math will lead us to have the purple be 340. Now because we're looking for something around and not shaded in, we know that we are looking for a arc length. So this is arc length in which we're going to be solving for. And remember, your arc length is always going to be the piece of the circle, which is 340, over 360. And then we're going to multiply that, of course, by the circumference formula, which is going to be 2 pi and r. And r in this case was 50. So please notice we didn't do anything with that 20. Okay? And again, this is something that you can put straight into the calculator as is. You do not have to do anything but put it right into the calculator. If you're confused about your calculations, maybe you do want to go ahead and reduce first. So you know that 10 can go into the top and the bottom and you'll get 34 over 36. You're probably thinking maybe 2 is your next best number. So 2 into 36, of course, can go. 117 times, and then 2 into 36, you'd have 1 and 8. And then, of course, 2 times 50 will give you 100 pi over 1. You can do that 100 and times 17 over 18. And that'll give you pi, and then you can put all of this into the calculator. It really doesn't matter what you do to get this as long as you put it into the calculator correctly. Okay, so let's go ahead and do that. Okay, so you want to make sure that once you put this in the calculator, it's going to give you 296.7. We don't want to write this because here in the last step it says to round your answer to the nearest foot. Remember, that means whole number. Okay, round to the nearest whole number. So to do that, we have to do 297 for our answer. Okay. All right, question number 19, of course, we did in class together today. Please excuse me. There was some labeling that we needed to do first. So we needed to talk about the circumference, we need to talk about the radius, we need to talk about the area of a parallelogram. So remember that this is a height, and then this here is going to be your base. Okay. Now remember, he got this from cutting a circle into 8 pieces. So remember, from the center of the circle to the outside of the circle is what we call the radius. So the height and the radius is approximately the same. We talked about the circumference. Remember, the circumference is the edge of the circle. So all 1, 2, 3, 4, 5, 6, 7, 8. All 8 pieces of this is going to make the circumference of the circle. But down here at the bottom, we don't have 8 pieces, we have 4. So therefore, that gives us half. It is going to be half of the circumference. And in order to really know what we're doing here, we definitely need to know what the area of a parallelogram is. So remember, your parallelograms, of course, your squares and your rectangles. And then also, of course, is the rhombus. So we got to know this formula. And remember, all it is base times height. Okay, simple, simple, simple. Now that we have this background information, we can go through and we can read and see which ones match up with what we know. So the very first one, which is A, says the height of a parallelogram is approximately equal to the circle's diameter. Well, we know that that's not true because we already said that it's approximately equal to the radius. So A is not going to work. B, the area of a parallelogram is approximately half of C. And if we go back up to see what C is the circumference and the radius. So let's look and see. Remember that the area of a parallelogram is the base times height, base times height, and then they're saying approximately half of the circumference, which is the half of the circumference, same as the base, times the radius, same as the height. So yes, we can choose B for one of our answers. The next one says the length of the parallelogram, and let's not be confused about length. Length will be similar to the base, so we'll write length down here as well. The length of the parallelogram is approximately equal to the circle's circumference. So this is where we have to be careful. This length of this base is equal to half of the circumference, not the whole circumference. So in this case, C could not work for us. It will not work. The next one says the radius of a circle. Here we have the radius of a circle is approximately equal to the height. Radius, height, radius, height. So we know that that's going to be D. And the next one says the area of the parallelogram is approximately 8 times the arc sectors. So this is the arc sector piece. So where do we get this 45 from? So remember that this used to be a whole circle, and we know that if I needed to solve for the central angle, I would just simply do 360 times the number of pieces that we cut this into, which was 8. And when we do that, we get a simple number of 45. So we know that the central angle is 45. To solve for this whole piece here, we would do 45 over 360 times pi r squared, which is exactly what we have here. That represents just one piece. But then once I multiply it by 8, 1, 2, 3, 4, 5, 6, 7, 8, it will give me the area of everything. So in that case, it would be equivalent to the area of a parallelogram. In question number 20, we did one like this in class, and I asked you to write your compass and do your never eat soggy waffles, just so you know in which location we're traveling in. And we'll start off with our cell tower. We're going to be going 35 miles, of course, east, and so that's to the left. And then we're going to go down south 42 miles, okay? So the starting point is going to be the park. The ending point is, of course, our tower. All right, we need to figure out the length from the tower to the park. Now, what have I created? Of course, I've created a right triangle, and my favorite formula we will be using. So that's going to be 35 squared, and then plus the 42 squared is going to equal C squared. So let's take some time to punch that into the calculator to see what we get. So 1, 2, 2, 5. And 1764 equals C squared. Remember, we need to add those two numbers together. And we're going to end up with 2989 equals C squared. And we need to square root both sides to get our answer. So we're going to end up with 54.6, but we can say 54.7. Okay, so we know the length from here to here is 54.7. So remember, the tower only emits up until 40. Okay, so we know that 40 40 miles it can go. We know from here to here it needs to go a distance of 14.7 or more for us to be able to hear the station, okay, or call or use our cell phones. I don't know. Let's go with cell phones, okay? Sorry. So here and here, when we select, we know we can only select the ones that are more than 14.7. And those will be our answers. In this one, number 21, we are looking to solve for our arc sector. So we need the arc sector formula. So we know that the arc sector, or area of a sector, is the same thing. Is always going to be equal to your piece of the circle, which is PC over 360. And then this time, since we're looking for the area, okay, everything shaded in, we're going to use the area formula, which is pi r squared. Okay. Now, they tell us what the area of the sector is. Area of sector is 642 pi. And that's going to equal PC over 360 times pi, and then of course your R is going to be 58 squared. Okay, so in doing our work, 642 pi equals PC over 360. Then we're going to do 58 times 58. Remember, this is inverse operation going on, so we can hit this up with a good division. Those cancels out, and we bring down everything else. We continue by going ahead and getting rid of the 3364. Remember, PC is the very last thing that we want to do. Okay, that's what we're solving for. Alright, and when we get to this section right here, this is where you want to do your cross multiplication. Okay, so that's going to be 3364 PC. And then that's going to equal a really big number. So I need to take the time to multiply it. Okay. That cancels out, and then we know that that PC is going to be equal to 68.7. Okay, so remember that your PC, arc PC, is going to be equivalent to your measure of angle PAC. This is your arc measure and your central angle, which they are the same. Okay, so that's area of the sector. And in this last one, we're going to do the Ferris wheel ride. Has a diameter of 60 feet. And each ride lasts for 3 minutes. And for each minute we can go around 2.8 times. So this is a simple mathematic equation where we're going to be just straight up multiplying all the way. So let's start off with what we're multiplying. First, since we're talking about going around, not the inside, we're talking about the circumference. And the circumference formula, of course, is going to be pi d. We're using the pi d because in this one it's talking about the diameter. And remember, your diameter is going to be 60 feet. So 60 times pi. Okay. We know 1 minute. 1 minute on the ride is going to be 60 pi. And remember, for 1 minute, we're going to go around 2.8 times. Now, of course, we ain't getting off the ride in 1 minute. We're taking a full ride. So this full ride is a full 3 minute ride. Sorry. A full 3 minute ride. Okay. And the full 3 minute ride, of course, is going to be 60 pi times 2.8 times 3. And this is what you're going to put into your calculator. Please remember that this is 60 times pi. 60 times pi when you put it into the calculator. And this is asking us to round to the nearest hundredth, so we need to make sure that we're careful with that. So 60 times pi, you got to hit the pi key. And then, of course, times 2.8. And then, of course, times 3. Okay. And then when you get that, we're going to have 1,583. And then that's going to be 0.36. 0.36. Okay. So this is going to be our final answer, just like that. Round to the nearest hundredth. Alrighty. That's it.